So inductive effect is broadly classified into two, that is plus I effect and minus I effect. Okay. Mainly this plus I effect is shown by some alkyl group. Okay. And minus I effect, you can easily predict minus I effect where you can have nitrogen, oxygen, halogen along with some electron withdrawing group. Okay. That is electron withdrawing group means carbonyl functionality. So suppose you have a carbonyl functionality. Okay. So this kind of where X means it can be amide, aldehyde, ketone, okay, ester. Okay. But your linkage should be through this carbonyl. Moreover, you can have a cyanide functional group, then SO3 H functional group, all these showing minus I effect. Okay. So how it is happening? We just check about that. Okay. So let's take an example. For example, CH3 function group. I am taking CH3 function group. CH3 function group having a positive charge, just okay, a hydrogen, hydrogen, hydrogen. Okay. The same time I am taking another bond, that is CH3F bond, simply CH3F bond. Okay. So we know that fluorine is the most electronegative element in the periodic table, having electronegativity 4. Okay. And carbon having 2.5. So according to the electronegativity concept, we know that the most electronegative element attract the shared pair of electrons. So what will happen? So we know that a pair of electron is present at this CF bond. So due to the electronegativity of fluorine, what will happen? This electron is more attracted towards this fluorine. Okay. So due to this electronic movement, we can see a partial charge development, that is here a partial negative charge, here a partial positive charge. Why? Because this partial charge is due to the little bit fluorine having a little bit much electron density compared to carbon. This is actually the inductive effect, that is the electronic movement via a bond or through a CC bond. Okay. Suppose if electron is moving towards a species, okay, that kind of inductive effect is called minus I effect. Okay. Then if electron is, so this is the one of the example for minus I effect. Why? Because the electron density is moved from this carbon center to this species, carbon center to this species. Okay. That's why it is called the minus I effect. It is moving away from this carbon center and it is moving towards the species. Okay. Let's check this example. We know that the electronegativity of hydrogen is 2.2 and electronegativity of carbon is 2.5. So according to the electronegativity concept, we know that electron movement or electron density is more towards more electronegative element. So while we are considering the CH bond, so we know that electron will move towards carbon. Okay, towards carbon. Okay. So we already mentioned that one of the example for plus I effect is CH3 or alkyl fragment. Why CH3 is electron donating? That is one of the most important question. Why CH3 is electron donating? Why CH3 is electron donating? The reason is nothing but while we are considering CH3 group, okay, as we mentioned earlier, carbon is more electronegative, that is 2.5, hydrogen is 2.2. So due to this, these three hydrogen will donate some electron density towards this carbon. That's why this carbon is somewhat electron rich. Okay. So this CH3 group act as electron donating group. Clear? So in precisely inductive effect is a electronic movement through a bond. Okay. നമ്മൾ നോക്കുകയാണെങ്കിൽ ഒരു പുഴയിലൂടെ നീന്തുന്ന ഒരു എഫക്റ്റാണ് ഇൻഡക്റ്റീവ് എഫക്റ്റ് എന്ന് പറയുന്നത് അല്ലേ. ഇപ്പോൾ ഒരാൾ ഒരു പുഴയിലൂടെ ഇപ്പോൾ CF3 CH3F എന്ന് കൺസിഡർ ചെയ്താൽ ഓക്കെ ഇങ്ങനെ ഓക്കെ ഇങ്ങനെ ഒരു നീന്തൽ ഓക്കെ. അപ്പോൾ പിന്നെ CH2+ ഇങ്ങനെ കൺസിഡർ ചെയ്താൽ ഇങ്ങനെ ഒരു നീന്തൽ ഓക്കെ. ഇത് നോക്കൂ, ഇത് കാർബൺ സെന്ററിൽ നിന്ന് എവേ ആണ് മൂവ് ചെയ്യുന്നത് ഓക്കെ. സോ ഇറ്റ് ഈസ് -I എഫക്റ്റ്. ദിസ് ഇലക്ട്രോണിക് മൂവ്മെന്റ് ടുവേർഡ്സ് കാർബൺ സെന്റർ. സോ ദിസ് ഈസ് +I എഫക്റ്റ്. ഇവിടെ CH3 ഗ്രൂപ്പാണ് +I എഫക്റ്റ് ആയിട്ട് ആക്ട് ചെയ്യുന്നത് ഓക്കെ. So it is very simple. So we can illustrate by using an example. Okay. എങ്ങനെ ഇൻഡക്റ്റീവ് എഫക്റ്റ് ബേസിസിൽ നമുക്ക് സ്റ്റെബിലിറ്റി ഒക്കെ പറയാൻ പറ്റും എന്നുള്ളത്. ഇപ്പോൾ ഐ ആം ടേക്കിംഗ് an acid. Okay. So CH3 C double bond OH acetic acid. Same way CF3 COOH. Okay. So among these two acid carboxylic acid, which one is more acidic? Okay. So since it is acid, it will donate H+. So you will end up with CH3 C double bond O-. So it is a anion, right? Here it is CF3 C double bond O-. Okay. So among these two situations, you will end up with the anion. So we know that according to the stability concept, we already mentioned our earlier class stability concept. A species which is stable means there is no any kind of charge. If a species having a negative charge, it will try to vanish that negative charge. If a species having positive charge, it will try to vanish that positive charge. Okay. In this situation, we can see negative charge. So in order to attain stability, this negative charge will vanish. So how it is possible? So while we considering these two ion, I am taking these two ion individually. CH3 C double bond O-. Okay. And CF3 C double bond O-. Okay. So here you have 3 fluorine atom. Okay. So according to our concept, inductive effect, here it is CH3's electron donating species, while we know that this fluorine is electron withdrawing species. Okay. So what will happen in this situation? CH3 will donate electron density towards this oxygen, and this negative charge will intensify. Okay. While in this situation, what will happen? This fluorine will attract electron density towards it. Okay. So it will try to vanish this negative charge. That's why this anion is more stable. It is least stable. So due to this reason, trifluoroacetic acid is more acidic than that of acetic acid. Okay. So if an acid is a strong acid, an acid is said to be strong, its conjugate base should be stable. Okay. So here this trifluoroacetate ion is more stable than this carboxylate acetate ion. Okay. So this is one of the application of inductive effect. We can discuss more effects in our next lecture. Okay. Clear? Thank you. Take care.